Hi guys, this is Mr. Smith, and you might be wondering why I'm looking at this spacecraft. Isn't it beautiful? It's marvelous. Anyways, the reason I'm looking at a spacecraft is because we are going to outer space. That's right, we are studying the solar system. So we're going to travel to different planets and see different worlds and see how far away the sun is and look at all sorts of information. So, without any further ado, let's launch! Hi guys, so don't worry, I made it. The launch was successful and I'm in outer space now. So this is Earth and we're just starting here. We're going to talk more about Earth later, but I thought we'd start here. We're actually going to study first. We're going to study the thing in the solar system that makes all life possible on Earth. Can you guys guess what that is? If you remember ecology, you know how producers made their energy. They needed what, guys? Does anyone remember? It's light from the sun. So we're going to go visit the sun. And I'm going to give you some information about the sun. So we're going to click sun here and we're going to go to... By the way, guys, this is a game called Space Engine. It's kind of like an online planetarium. It's really, really done well. I really enjoy it. I've actually done some videos for one of the other teachers at Solterra. And their class really liked it, I think. So I thought we could do it too. So this is the sun. So we're going to look at some info about the sun. So Sol, or the sun, is the star at the center of our solar system. So that's why it's called the solar system, because the word Sol. It's almost perfectly spherical and consists of hot plasma interwoven with magnetic fields. It has a diameter of 1,392,684 kilometers, about 109 times that of Earth. So it is very big. It's much bigger than Earth. And its mass accounts for about 99.86% of the total mass of the solar system. Okay, chemically, about 3/4 of the sun's mass consists of hydrogen, while the rest is mostly helium. So that is what the sun is made of. The distance of the sun from Earth is approximately 149.6 million kilometers. It's actually 93 million miles if you want to look at miles. Though the distance varies as the Earth moves from... That's some big words. As the Earth moves closer and farther away from the sun, but it's close to 93 million miles away. At this average distance, light travels from the sun to Earth in about 8 minutes and 19 seconds. The energy of this sunlight supports almost all life on Earth by photosynthesis and drives Earth's climate and weather. So the sun is very, very important to Earth. Earth would not be a livable planet without the sun. This screen is like a map of the solar system. It's only aligned this way to show what order the planets are in. They still orbit at different speeds. But if we close in here, we can see that's how big the sun is, and that's kind of gives you an idea for how much smaller the planets are. So we'll zoom in a little bit, and you can see all the planets in our solar system. And some of these aren't actually considered planets. But we have Mercury, Venus, Earth, Mars. Then we have Jupiter, Saturn, Uranus, Neptune. Those are all the things considered planets. See, I would still consider Pluto a planet because it always was a planet when I was a kid. But they're saying now that Pluto is not a planet. What's cool about this too is I think you can see a faint ring around Neptune. Really is a good program. And then all these things are just minor planets. These are actually what they think Pluto is too. So anyways, the next thing we're going to do is going to show you like how important the sun is to our solar system. So this is another game all about space. This is called Universe Sandbox. And you can do a lot of really interesting things with this. But like I said, I wanted to show you how important the sun is to our solar system. There's the sun right there. There's Mercury, Venus, Earth. Mars is here somewhere. Mars. So it says here, welcome to our solar system. So I'm going to click next. This is the Earth. It is home to everyone you know. That's true. You don't know anyone from anywhere else. And this is the sun. It is the most important source of fuel for life on Earth. That is true. What if we got rid of it? So what would happen if we got rid of the sun, guys? So it says click tools. Nobody panic, we're not really getting rid of the sun. Select delete. Select the sun. Alright guys, get ready. This is what happened if the sun went away. Without the sun, our entire solar system falls apart. And Earth gets a little chilly. Guys, look how cold it is. So the sun is very important. So let's go back. I don't know if I can get out of this. Click and drag to rotate the camera. I'm going to go through this and come back to you. So guys, I slowed things down. Another thing I want to show you about the sun and our solar system is why life is actually possible on Earth at all. And that's because our solar system has what's called a habitable zone. So if we look here, we can actually click this and it'll show us where life would be possible. It's not definitely going to happen in a habitable zone, but it's where it's possible. The conditions are correct. For instance, if we look at this, blue is, what do you think, guys? Blue is too cold. Red is too hot. So green is just right. So if you look, Earth is actually close to the middle of this habitable zone. Here's the thing. Mars is here too. Mars doesn't have an atmosphere, so Mars can't sustain life. We'll talk more about that when we talk about Mars. But the sun is it's amazing because the sun is exactly the right distance away from the Earth. The Earth is exactly the right distance away from the sun. And we're in a spot in our solar system where life can thrive. And we can have, you know, this wonderful place. Now, the only thing I would say is these other places don't have COVID-19. But that's another story. So, anyways. So this is Earth and this is the sun. So one more thing before we go. I'm going to slow things down. What if we had a different sun? What if the sun was a different size? So I'm going to actually pause it. I don't know if we should do a bigger sun or a smaller sun first. So we're going to, while it's paused, we're going to delete the sun. And we're going to add a different size star. So it doesn't really say which ones are bigger and which ones are smaller. This one's 94.3 Jupiter. It's a very big star, I think. So this is another star we could add. So this is actually Sirius. So let's see what happens when we put Sirius in the middle instead of our sun. We'll unpause it. Now we'll look at this too. The habitable zone changed a lot. Do you see that? Now the habitable zone is way out where Jupiter and Saturn are. So let's unpause the game, the simulation, and see what happens. We'll speed things up a little bit too because it's going to take some time. So Sirius has a lot more gravity than our sun, so it really messes things up. And Sirius actually isn't staying still where it's supposed to. So, okay, so we're going to have to restart because the whole solar system is collapsing on Sirius. So we're going to restart. We'll try one more star. Let me pause the simulation. We'll delete the sun. We will add. We'll add this guy. Right about in the middle. So this is Polaris. So this is actually a little bit bigger than our sun. It's 1.3 the mass of the sun. So let's see what happens here. Oh, that really did a thing. So that didn't work out so good either. Let's see how things are on Earth at this point. It's probably not very good, huh? Oh, it goes really fast. So the Earth is freezing, I think. Yeah, the average surface temperature now is 374, so that's not actually freezing. I think because that star was so much bigger and had more gravity, it made things hotter. Anyways, guys, that's going to do it for this first episode, talking about the sun and how important it is that the sun is perfectly the way it is. Look at how screwed up the solar system is with that other star. Anyways, guys, thanks for watching. Hope you enjoyed this video, and have a good day. Hope you learned something. Bye!